Okay, welcome to video 4. Here we're going to be talking about exponential decay. Well, if you recall from what we talked about in the last video, the cost of Bob's house in 2005 was $220,000. If his house appreciates in value at a rate of 3.5% every year, what will the price of his house be in 2015? Well, we solved that by writing our exponential equation. Since it's growing at a rate of 3.5% annually, I changed that to a decimal and put it into the equation. Then we can go ahead and change this to then find the price in 2015. Well, from 2005 to 2015, that's 10 years later, so that's going to go in for my x. And when we do that, we get 310,331.7273, which we then have to put as a real life answer. So my final answer is this $310,331.73. So those were exponential growths. They were going up. Something was happening to make them increase. Well, now let's look at a new example. A ball is dropped from a height of 100 centimeters. When it hits the ground and rebounds, the new height won't be as high as it was at first. The height after each bounce decreases by a rate of 20% from the previous height. What would the height of the ball be after the fourth bounce? Use the table below to help you find the answer. So if we look at this, if we start off with at the zero bounce, the height of the ball is 100, and 20% loss will lose 20, because 0.20 or 20% of 100 is 20, and the height minus 20% lost will then now be 80. So 80 is our new height. So what's 20% of 80? That's what we're going to lose. So that's going to be, if I do 0.2 of 80 in my calculator, I get 16. So my new height is 16. What does that mean for what I've lost? Well, the new height, the original height, 80, minus the 16 gives me 64. So that is my new height. So 64 is my new height. 20% of that is going to be 12.8. And if I subtract, my new height is going to be 51.2. And we're going to continue that on. So 51.2 minus the 10.24 will give me 40.96. And then after the fourth bounce, we can see that it's 32.768. So what did we find out about the height of the ball after each bounce? Well, what we did each time was multiply the height by 0.20 or 20% and subtract that from the height in order to find what the new height was. So what is the ratio between the value after one bounce and the start height? Well, after one bounce and the start height, that was 80 out of 100, which is 0.80. Now let's do that again for what is the ratio between the height after two bounces and the height after one bounce. If I do that, I get 64 out of 80, which is also equal to 0.8 or 0.80. Now again, I'm going to do that for after three bounces and the height of two bounces. And imagine that I again get 0.80. So we have that common ratio of 0.80. Each time it's 80% of the height. So what does the value 0.80 have to do with a 20% height loss? Well, the 100% minus the 80% is what gives us the 20%. So the 0.80 and the 0.20 add up to 1. The new height is always 80% of the original height. So we can do this whole 1 minus what we want, the percentage that we're losing, 1 minus the 0.20 to end up with the 0.80, what we're trying to multiply by. And that'll help us with our exponential decays. So recall again that our equation looks quite similar to the formula we used in the last two lessons for exponential growth. Is the height of the ball's bounce increasing this time? Well, no. Now the height is decreasing. So what about the equation C of t equals 100 times 0.80t could tell you that it is not a growth model? Well, I think that it's the B term, or growth factor, is less than 1, showing that it is a decay. Okay, we'll talk about this more tomorrow. Have a good night.